In this video, we'll talk about JSP expression language. Expression language was introduced in the JSP 2.0 specification. The syntax of expression language is very simple. Just a $sign, a pair of braces with an expression inside. Expression language is mainly used for accessing data and their properties in JSP. Here's a list of things in a typical programming language, from the simplest comments to the more complex, like classes and packages. Expression is in the middle. Expression in a programming language is anything that evaluates to a single value. For example, a single value, say 10, is an expression by itself, or a variable a would also be an expression by itself, and if they combine together, it's still an expression because it will evaluate to a single value. An expression can be fairly complex. For example, we can have 10 plus a times b minus c plus 200 or something like that. It can be as long as it can be, but eventually if it evaluates to a single value, it is an expression. Now, the good news here is that expression language, as the name says, only has things up to expressions. In other words, there's no statements or functions or any of those more complex language constructs. So learning expression language is actually pretty easy. We'll start with comments. Comments are actually not part of expression language, but I'll cover it here anyway, since it kind of makes sense. There are two types of comments you can include in a JSP file: the regular HTML comments and the JSP comments. As far as JSP is concerned, HTML comments are the same as other HTML text, so they will be rendered in response. If you use HTML comments, remember that users can see them if they view the source of the page. We can take a look at a quick example. I have a JSP page here, and let's quickly run this. And we'll go to els.jsp. Nothing here because my page doesn't display anything. Let's put something like hello here. Okay, so it says hello, and we can add a HTML comment. We'll say this is a HTML comment, and we can also add a JSP comment. This is a JSP comment, and if we come back and refresh, neither is displayed by the browser. However, if we do a view source, we can see that the HTML comment is in fact included in the response, and a user can simply do a view source to see it. JSP comments, however, are comment in the real sense is not included in the output. Okay, after comments we have literals, variables, and operators, and they can be combined to form expressions. Let's first look at literals, or in other words, values. We can use, these are the literals or values we can use in expression language. As we can see, they are mostly the same as in Java. You have Boolean values, true and false. You have integers. You have floating point numbers, and you have null. The main difference is that in expression language, strings can be either single-quoted or double-quoted, using double quotes or single quotes. And this is just like in HTML. And there's no character type. In Java, remember, character values are enclosed in single quotes. Since here single quotes are also used for strings, there's no character type here. Now, what about variables? Well, first of all, know that you cannot define new variables in expression language, because after all, it's expression language and you need statements to define new variables. However, we can use expression language to access existing objects, both the so-called implicit objects and the objects we stored in scopes like application, session, and request scope. Before we look at those objects, we need to first explain a very, very important term called property. When we learn Java, or any object-oriented language for that matter, we learn three terms: fields, constructor, and methods. Fields are like first name and last name here, and constructor, of course, is a special method that creates the object, and of course we have the methods. Notice that none of them is called property. So what about property? A common misconception is thinking fields are the same as properties. At least in Java, they are not. In Java, properties are defined by getters and setters. They are related to fields, but not the same. For example, here I have two fields, first name and last name. But I actually have three properties: first name, last name, and name. Each is defined by a getter method. Here are a few important things about properties. The first letter of a property's name must be in lowercase, and that first letter must be capitalized in getter and/or setter. By the way, getter sometimes is also called an accessor, and the setter is sometimes also called a mutator. Sometimes we only have a getter, like in this example. We say that that getter defines a read-only property. If we only have setter, we say it defines a write-only property. If we have both a getter and a setter, we say they together define a read and write property. So knowing what we know, let's look at an example. Let's say we have a class here, and this class has 4 fields. Remember that fields are not properties, so we can actually just ignore them. Let's look at these getters and setters. So first of all, we have a get A and set A here. We have getter of A and setter of A. Together, they would define a property called A. Remember the naming convention. The first letter must be in lowercase and it's capitalized in getter and setter. So the getter and setter says get and set capital A. The property name, in fact, is lowercase a. Property names are case sensitive, very important. So it's lowercase a, not capital A. If we look at B, there's only a getter, there's no setter, so we have a property B and it's called a read-only property. C, on the other hand, has a setter, so it's write-only, and here we have get AB. Notice that get AB does not correspond to any of these fields, and that's okay. Properties have little to do with fields. I shouldn't say have nothing. because most of the time getters and setters are defined for fields, but their properties and fields are two separate concepts. Here we have get AB, that means we have a read-only property called AB, and again notice that the first letter is lowercase and it's lowercase ab, not capital AB. Now how about the last one? We have a setter on E, and then we have a method called isE. Normally, a getter is named getSomething, but there is an exception. The naming convention is that if the type is Boolean, then the getter name is named isSomething rather than getSomething. So in other words, isE is indeed a getter, and this isE together with setE makes E a read and write property. So we have a read-write property E here. Here, remember, isE is in fact a getter, and the naming convention is if the property is Boolean, getter is isSomething rather than getSomething. Now let's look at this example. At the first look, you may think that we have 1, 2, 3, 4 properties. A, read and write, B, read only, C, write only, and D, write only property. But if we take a closer look, we'll see that A, B, C are in fact not properties. Only D is a property. Why is that? Well, it's important to remember that if a method is called getSomething, that doesn't automatically make it a getter. In fact, a getter, in order to be a getter, it must not have any parameter at all. And similarly, a setter must have exactly one parameter in order to be a setter. So notice that here, getB actually takes a parameter. So even though the name of the method is getSomething, because it has one parameter, this disqualifies it from being a getter. So this is simply a regular method, just happen to be called getSomething. It's not a getter, so it doesn't define a property. Similarly, this method setC has two parameters, and a setter can only have one. So setC again is not a setter, it's just a regular method that happens to be called setSomething. setD, by the way, is indeed a setter having exactly one parameter. So that's why D is still a write-only property. Now the case of A is a little bit tricky. If you look at get A and set A, it seems to meet the requirement of getter not having argument and the setter having exactly one argument. What makes this not a property is because notice the different type in the getter and the setter. In the getter, the return type is integer, means that this property, by looking at just getter, should be an integer property. However, the setter takes a string value to be the value of the property, and this is inconsistent with what the getter says. Getter says it's integer, but setter says it's string. It's important to understand that even though properties are defined by getters and setters, just like fields, they still have types. And the type of a property must be consistent in both the getter and setter. So here, A is in fact not a property. If somehow we can change this to string, or somehow we can change this to int, then it will become a string or int property. As you can see, there are lots of details in the getters and setters and how properties are defined. So my recommendation is that when you create a class in Eclipse, for example, if we create a class called C, and let's say we have a int some field, and if you want to create getters and setters for this field, instead of doing it manually, which tend to lead to typos and errors, just let Eclipse to generate the getters and setters for you. So you can right click and select source and select generate getters and setters and check, or you can only generate setter or getter and let Eclipse to do it for you. Eclipse will ensure that they are valid getters and setters. Let me delete this. Okay. So now that we know what properties are, let's see how to use them in expression language. It's actually quite simple. The syntax is simply $, braces, and then the object name, and dot, then property name. I have two classes here, one called A, one called B, and I have some properties in both A and B. So you can look at the code. There's not too much, just a bunch of getters and setters, and same thing for B. So I summarize the properties here. So for class A, I have an int property called ID, get ID, set ID. I have a string property called name, and I have a string array property called weekdays, which has value Monday, Tuesday, Wednesday, Thursday, Friday, and notice that we have weekdays string property, and I have a list of integers, which is a property called number. So numbers, not number, and I initialize some random numbers in them. So this is my A class, 4 properties, ID, name, array, and a list. And then I have a B class, which has 2 properties, a property called A0, get A0, set A0, and A0 is an object of A type. And it also has another property called list A, get list A, set list A, and the type of list A is a list of A objects. So I also have a controller here, and in this controller I created 2 objects, one A object and one B object. I store them in request scope. One is called A, one is called B, and then I forward the request to this JSP called property test.jsp, which looks like this. Right now I already have a little bit code here, and the first one is an expression language, expression that says a.id. Now if we look at the object, if we look at the code, we can see that id is initialized to 0, so we probably should get 0 here. And I also have b.a0, and b.a0 would be a object. So if we run the code, let's see how it looks. if we go to property test, it says 0 and then it says this object. So a.id give us 0, which is the value of the id property of a, no surprise here. And b.a0 give us the a0 object of b, which is a object of type A, which looks kind of weird like this. So first of all, know that this is in fact what you get when you try to print out an object. By default, the toString method of an object will print out something like this with the object class name, and this one is, I don't know, some hash code of the object or something like that. So this basically says that we are getting an object which is a0. So it's okay. We'll look at this a little bit more in a moment. So let's look at first the other properties of object A. We have an ID property, we also have a name property, string property, and so on. So let's do this one. A's name, we can say a.name. Notice that A is the name of the object stored in request scope, and dot name is a property, so it should display the value of that property, which is indeed this. And if we do weekdays, we can say weekdays, a.weekdays, we have a weekdays property. And if we do that, this is what we get, because weekdays is a string array, and we get something that looks like this. Obviously, that's not very readable. So how about we get weekdays, the first one. We can say weekdays, the first weekday. Now this one, we know what it is. It is the first element in the array. What this one tells us is that if you try to print out the whole array, you'll get something like this. But you can go through the array by specifying the index, and you can print out the array values one by one. And in fact, whether it's an array or whether it's a list, you can do this for both. So I also have a property called numbers, which is a list of, is it a list of integers or a list of doubles? It's actually a list of doubles, not a list of integers. So if I say numbers 0, this will print out the value of the first element in the numbers list. So this is what we can do with the A object and all its properties. And let's look at B object. B object has a property called A0, which is an object by itself. So that means we can do something like this. we can do b.a0.id. And it gives us 0. And we can do b.a0 name. Give us this one again. And B also has a list of A. We can say B dot list A 0 dot name, something like that. And B dot list A 0 dot name. And this is what we got. So most of that are what we kind of expect. The syntax is really pretty simple, just object name and then dot property name, and it will give you the property value. Here I just want to emphasize two things. First, very importantly, property itself may be an object that has its own properties, like A0. So we can do object dot property, and if this is a property, we can keep doing this. And secondly, we can use index to access objects in elements in both array and list. So we can do weekdays 1, weekdays 0, or numbers bracket 0, numbers bracket 1. And besides the so-called scoped variables, which means object we stored in scopes, we can also use expression language to access the so-called implicit objects. Implicit objects are a number of objects that are already defined in expression language, like page context, param, cookie, and so on. There are also request, response, session, and servlet context, which are properties of page context. Let's use an example to see how to use these implicit objects. I have another servlet here called request info, and here I store two objects. Notice that both objects are called hello, and I store one in session using session set attribute, and the value for that is word, and I stored another one with the same name, value being CS3220, and I store it in request scope. So two scoped variables, same name, in different scopes. And then I forward the request to requestinfo.jsp, which is this one. So let's start by doing first. Let's say I want to display the request method and the client address. So how do I use implicit objects to display request method and client address? Well, remember, we've seen the API of HTTP requests before. If we want to get the request method in in servlet, we can say request get method. But in JSP, notice that get method, in fact, is a getter. So in expression language, we can simply say request.method, and that should give us a method. Similarly, if we want to have client address, we go to the API and we find that getter. Where is that getter? Here. It's called get remote address. Yes. So notice that it's called get remote address, and it's a getter. So that should let us to use remote address as a property directly. Now, in implicit object, we don't have access to request directly, but we have access to page context. And if you look at the API.implicit of page context, you can see that, hey, there's a getter called getRequest. There's a getter called getResponse, and so on and so forth. So in other words, request, response, and servlet context, session, and so on are all properties of page context. So knowing what we know, it's pretty easy to do. So we'll say something like request method is page context dot request dot method, and the client address is page context request remote address. Yes. If we go to request info, we get and the IP version 6 address of the local host. And what if we want to display the two objects in the request scope and the session scope, which is here? So I have an object, both variables or objects are called hello. One is word and one is say 3220. And if we simply say hello, this will give us say 3220, and that's the one in request scope. So what if we want to get the one in session scope? These are what these implicit objects do. We can do request scope dot hello, request scope dot hello, and we can do session scope dot hello. So request scope hello is CS3220, and the session scope hello is word. So in other words, these implicit objects let us to specify which scope we want to use, and then we can specify the object in that scope. There is, in fact, a second syntax. We can do, instead of using the dot syntax, we can also use, this is request scope hello, this is session scope hello, and we can also do it this way. We can also use bracket syntax, say hello, and this one is session scope. Hello. So it will give us the same thing. Notice that if we use the bracket syntax, make sure that the name of the object should be specified as a string. Okay, so what else? Display the value of a request parameter. Okay, so request parameter is probably something that you would want to access in a JSP, and that is using param implicit object. So we'll say parameter a, and we can do param.a. And if we refresh, it doesn't show anything because there's no request parameter, but we can add one. If we specify a request parameter, now it shows 10. And similarly, we can use the bracket syntax, param a. So either the dot syntax or the bracket syntax. And one more thing, if we want to get a particular cookie value, we can do, for example, value of the cookie J session ID, and it will be cookie dot J session ID dot value, or it's cookie bracket J session ID dot value. So looks like this. Again, the actual code is pretty straightforward. I just want to emphasize two things. First, understand that these implicit objects are really still Java objects. So if you want to find out how to use the object, just read the API documentation and look for properties like get request, get method, and so on and so forth. And secondly, expression language allow us to access elements in a collection using both bracket syntax and dot syntax, like param.a and the param bracket a. Forgot the brace here. By and large, accessing implicit objects in expression language is actually not that common because processing is supposed to be done in controllers. The only thing that you'll probably do once in a while is to check if a request parameter is present in a JSP. So make sure you know how to do this. The others are not quite as important, except, of course, accessing scoped variables, which you'll do all the time. Okay, we have looked at values, we have looked at variables, and now the operators. Here are the operators in expression language. They are mostly the same as Java operators, except a few of them, which I highlighted with a different color. Most of these are actually just alternative way to write the same operator. For example, div is the same as slash, mod is the same as the percentage sign, which is a modulus operator in Java. So they are not new operators. They are simply a different way to write the same operator. Same thing for the logical operators. You can use the Java syntax, or you can use and, or not. And same for the relational operators. You can use the Java syntax, or you can use EQ, not EQ, LT, and so on. So these are just same operators. You can use two different ways to write them. The only operator that's significantly different, in fact, there's no equivalent in Java, is this empty operator. In Java, if we want to check a value is null or empty, we have to do two checks. We have to first check if the value is null, and then if it's not null, we have to do a second check. In expression language, this empty operator let us to do both check at the same time. It will treat null and empty as the same, which is quite convenient on the web, because oftentimes on the web, we sometimes don't get anything, or we get an empty string, and the empty operator is quite convenient to check for those situations. Now, with that being said, although most expression language operators look the same as their Java counterparts, sometimes they behave a little bit differently. So you need to be careful when you first use them. I have a few examples here. We'll try a few of those and see how they differ from the Java code. So let's start with the first one. The page we are going to use is EL test. Let's go back to here, and let's say we'll create an expression, and then we'll put in 2 plus 4 over 2. And if we go to EL test, so 2 plus 4 over 2, it gives us 4.0. Now, technically it's not wrong, of course, but you can probably see the difference between this and Java. In Java, if all the operands are integers, the result would also be an integer. So 2 plus 4 over 2 would give you 4 as an integer instead of 4.0 as a floating point number. So just by looking at this, you can probably tell that expression language does calculation in floating point number. It does not keep integers as integers. And let's try this one. So we have a string 2 plus 3 over 2. And the result is actually 3.5. So in other words, expression language automatically convert this one into a number, and 2 plus 1.5 is of course 3.5. So this is another feature of expression language, meaning that things on the web, essentially everything is text. To make development easier, expression language tries to do conversions automatically in certain cases. So you can imagine, for example, instead of you having to write code to do integer.parseInt all the time, it will tries to convert the a string into integer automatically for you. In this case, it's giving us 3.5, which is what we want. What if we try to add a number with a string? In this case, we actually will get an exception. The exception is number format exception for string A, meaning that it actually tries to convert this one into a number to add up with this number, and this one will be an exception. So in other words, sometimes the automatic conversion is good and works, but sometimes the automatic conversion is not good. It's difficult to figure out all the rules. So my suggestion is that if you are unsure, just do a simple example like this to see if it would work. And in this case, it would not. Unlike in Java you would have something like A1.5. The second part automatically gets converted into a string. But in expression language, it tries to convert this one into numbers instead, and it will give us exception. So let's try this one, empty. So empty, as I said, is an operator that's not in regular Java. It's an operator specific to expression language, and it checks whether something is either empty string or null. So if we use empty to check empty string, it will say true, of course. So this one will return true. And if we try null, it's also true. If it's actually a string null, it will say false. I'll leave the rest for you as exercises, but you'll see that expression language by and large makes simple things quite a bit easier. So this is the end of the story about expression languages. As you can see, it's a very simple language, very easy to learn and very nice to use. The syntax is nice and clean and makes the JSP a lot more readable than embedding Java code. The problem, however, is that it only has expressions, and sometimes that's not enough. For example, we can display individual elements inside a collection, but we cannot display all the values in an array or list because that would require a loop statement. So to go from expression to a statement, we need something more. And that will take us to our next subject, JSTL. So this is the end of this video. See you in the next one.